Hello everybody, welcome to Raaonline. The topic for the present discussion is antigen, and this is an important topic under immunology, okay, in microbiology, and I propose to cover it under the following headings. So what is the definition of an antigen, how we classify antigens, then determinants of antigenicity, what are the properties of an antigen, and what are the biological classes of antigens. Okay. So now first coming on to the definition of an antigen is defined as any substance which when introduced into the body of a host, it can be a human being or an animal, it stimulates an immune response and it also reacts specifically, okay, by binding with the effectors, okay. It can either be the effector molecule, which is an antibody, or the effector cell, which is the lymphocytes, or both. So it is a substance which stimulates an immune response and it reacts specifically with the product of the immune response. So that is an antigen. So the two important properties or aspects of an antigen are immunogenicity, that means ability to induce an immune response, and immunological reactivity, where it is able to specifically react with the antibodies or the sensitized cells. It is a specific reaction. So an antigen, when it stimulates an antibody, it reacts with only those specific antibodies and not with antibodies stimulated by other antigens. And just to again memorize it, B cells are the B lymphocytes. When they are exposed to the antigen, they become effector B cells. That means they get changed into effector B cells or plasma cells. Okay, and these plasma cells will produce all the antibodies, okay, which are nothing but proteins. And also in addition to effector B cells, it also produces memory B cells, and these are only responsible for protecting us against the next infection or the secondary infections and reinfections, okay. And then you have the T cells, okay. T cells, when they are exposed to the antigen, they produce effector T cells, and effector T cells can either be helper T cells or cytotoxic T cells. In addition to producing effector, they also produce memory T cells. So this is how the antigen will trigger your immune response. Now, I told you it reacts specifically, and the specificity is very important, and it's the hallmark for all immunological reactions. So when an antigen is introduced into the body, it reacts only with those specific T cells or B cells which have that particular marker which is complementary to that antigen, okay. And they will produce antibody or cells complementary to that antigen only, okay. So, and based on the ability to carry out these two functions, we told two functions are the immunogenicity, immunological reactivity. Based on these two functions, we can classify the antigens into complete antigen and incomplete antigen or hapten. So, when you say complete antigen, they do both the functions, okay. That means they induce antibody formation or immune response, they induce the immune response and they can react specifically with the antibodies so produced and produce an observable reaction, okay. Whereas haptens or incomplete antibodies, they are unable to induce the antibody formation by themselves. But suppose the antibodies are present, they are able to react with them, okay. So complete antigens do both, incomplete antigens or haptens cannot induce but they can react. So that is the thing. So this is a picture of a complete antigen and a hapten molecule. But however, the hapten can be made to induce and then react by means of lacking this, okay. You can latch this on to some carrier molecules, then they become complete antigens and they can induce an immune response. So haptens become immunogenic when you link them onto larger molecules, okay. So that is only hapten. Actually, it is got from the word haptein, H-A-P-T-E-I-N, which means to fasten, F-A-S-T-E-N. You fasten it or you attach it to a larger molecule, then they become like complete antigens. And you can classify haptens as complex or simple. Just know that complex haptens, when they react with specific antibodies, they can precipitate. So they form a visible reaction. So you can see a precipitate happening. Example, the capsular polysaccharide of pneumococci. Whereas simple haptens can combine with the specific antibodies, but no precipitate is produced. Because a simple hapten is univalent. That means it has got only one antibody combining site. And so, when it binds to a specific antibody, so no lattice or any network is formed. So, it does not produce any precipitate. Okay. So the disadvantage of these simple haptens is that suppose you have complex haptens or corresponding antigens are there. The simple hapten, if it goes and binds to the antibody, it will inhibit the precipitation by going and blocking onto the antigen binding site, okay, of the antibodies. Another important term which you need to know when we are dealing with antigen is that antigen determinant. Okay, antigenic determinant is the smallest unit of antigenicity. Okay, so it is also called as an epitope. So if you see this as the full antigen molecule, okay, there will be one area on this antigen molecule, and this may be just having about 4 or 5 amino acid linkages, okay, or monosaccharide, that means simple sugars, okay, they may be just 4 or 5 molecules of amino acids, okay, and this will form what is known as an epitope. And so epitope is the smallest unit of antigenicity, and what we need to know is on such a big antigen molecule, you'll be having many epitopes like this, okay, each one will be having its own structure, electrical charge and spatial configuration. So actually if you see a molecule of an antigen is a mosaic of many of these kinds of epitopes, okay. And once this epitope, okay, it is actually a small antigen on a big antigen, okay, it can sensitize an immunocyte, that means an immune cell, and what it can do is on its site, you see there is an antibody binding site, and this can react with the complementary area which is present on the specific antibody or the T cell. So in one antigen, as I told earlier, there will be many of these determinants, and each one of this determinant or epitope will induce a specific antibody formation, okay, and the combining area on the antibody corresponding to this epitope is known as a paratope.